Hello everyone. Today we're going to be doing another lab for the Sierra College Physics Department, Speed of Sound. This lab is determining the standing wave on a string. In front of you there's a frequency generator connected to a speaker, and that speaker has a wire. That wire goes over a pulley, and on the other side hangs a mass. The goal of this experiment is to adjust the frequency on this generator such that we determine resonance or standing waves on the string. So we're going to go through the first standing wave. And what I'm looking for is, as I adjust the frequency up and down, it is going to allow this string to vibrate. And I'm going to adjust the frequency so that that vibration becomes its peak or largest. It's very difficult to see, so you're going to have to take my word for it. So right now I have a node here and a node at the end, so I have 1/2 of a wavelength at 31.0 hertz. I'm going to move up a 1/2 a wavelength, so I'm going to adjust the frequency. And what are we going to adjust it to? We're going to adjust it to a resonance number, and that resonance should be a multiple of 31. So I'm adjusting it up. And lo and behold, I have a 1/2 a wavelength, a node, another 1/2 a wavelength, and right now it's at 62.1 hertz. We're going to adjust it up again, and we're going to expect it to be a multiple of 31. So as I go up, 80, 87. Oh, I passed it. That looks actually really good to me. Oh, and look how it is. It's 93 hertz. So again, we're at our multiple. So a 1/2 a wavelength, a 1/2 a wavelength, and another 1/2. Let's see if I can get one more. And I get one at 124.1. Your lab asked for 5. I don't know if I will get it. And I get the 5th one, so there's 5 1/2 wavelengths at 155.8. Look for the supplemental pictures that'll be attached. Those will be your measurements. You're going to have to look at the picture and determine the measurement for yourself. Thank you. Hi everyone. Today we're going to be doing the Physics Department Speed of Sound Lab. This is part 2, determining a standing wave in a tube. The apparatus before you has a frequency generator set to 426.6 hertz. That is approximately the tuning fork as noted in the lab. The apparatus is a speaker and a tube filled with water. On the side of that tube are measurements. So I'm going to play the tone and adjust this up and down, which raises and lowers the water level. I'll then adjust it down until I reach a resonant frequency. I will note that by the amplification of the sound coming out of the speaker. I'll take a picture of that measurement, then lower it one more time to reach the second harmonic, and that will show you the number of standing waves or partial standing waves inside the tube. And from there, you can use the two measurements to determine the speed of sound. Hi everyone, and welcome back to the Sierra College Physics Department Speed of Sound Lab. Now we're going to be determining the speed of sound in air and in helium. So the apparatus before you is a closed tube with a speaker at one end, a microphone, and a cork at the end. We have a frequency generator exciting the speaker, and the microphone is attached to an oscilloscope. The measurements to be taken today are the distance from the microphone to the stopper and the time it takes to do that distance. From distance and time, we'll determine the velocity or speed of sound in air, and later fill this with helium and determine the speed of sound in helium. So what are we actually measuring? We're measuring the distance from the center of the microphone to the end and back. So we're going to be looking at the echo, the time it takes to go from the microphone to the end and back. So let's take a look at the oscilloscope. This first sound is when the sound created by the speaker hits the microphone. This second one is the echo, so going to the end and back. This third little one is it bouncing off the speaker and back to the microphone. So we're not doing this third echo, just the first to the second. So there's large boxes on this oscilloscope, and each large box is a division. And each small line is 0.2 of a division. So I will move that up. And now you need to stop the video and take the measurement from the largest line here to the largest line here. That'll give you the number of divisions. We're going to then move over and look at the settings. And right now it's set at 1 millisecond per division. 1 millisecond per division. For example, if I wanted to measure 2 divisions at 1 millisecond per division, that distance would correspond to a time of 2 milliseconds. Look to the supplemental pictures to get the measurement from the microphone to the end of the stopper. Thank you, and look for the other measurements for helium.